Okay, dear students, let us read this question now. The frequency of the first harmonic in a pipe is measured. An adjustment is then made with which causes the speed of the sound in the pipe to increase. So something has been done that the speed of the sound increases. Fine. What is true for the frequency and the wavelength of the first harmonic when the speed of the sound has increased? Okay, the frequency of the first harmonic in the pipe is measured. So let us say, like, it's not given that the pipe is open or the closed one or something. Anyways, we can just use our general formulation, and or we can say that the frequency will be directly proportional to the velocity divided by length of the pipe. And so something happened that the velocity has changed, the speed has increased. So what happens to the frequency? So obviously the frequency will increase because they are directly proportional to each other. So frequency increases. Okay, so there is a pipe and the standing waves are becoming forming there. So the frequency will be given by some formula. Either it will be like both ends open or one end open, and we can use those formulas to find the first harmonic. Later they say that the speed of sound has increased, but the length of the pipe is untouched, so it remains the same. So length remains the same, but the velocity increases. It only means that frequency has to increase, simple. But what about the wavelength? Now, because the frequency is now directly proportional to the velocity, we can say that velocity is equal to lambda into frequency, and v by f remains the same because more is the frequency, more is the velocity. So both of them are literally directly proportional to each other, hence the wavelength will not change. And there is another reasoning for this, because in our standing waves, what we do is we always equate our length of the pipe with the lambda by 2 many a times, or like whether if it is first harmonic and the pipe is open from both ends, so the length is equated with lambda by 2, isn't it? Now the length is not changing, so it only means that the wavelength is not changing, isn't it? So accordingly, we can say that the wavelength does not change, but the frequency increases, and yes, the answer will be A. Let us check it from the mark scheme, and then we see, yes, the answer is given as A. So my dear students, this is Professor Varun. Please subscribe to the YouTube channel and share the YouTube channel with all your friends. All the best.